Alright, so we're going to continue with chapter 1, section 6b. We're going to solve other types of radical equations. So in the previous section, we just did square root equations, and now we're going to do equations that are maybe cube root equations, fourth root equations, and we're going to see fractional exponents as well. So the process is going to be the same. If you have a square root, you would raise it to the second power. Now, if you have any other root, you would raise it to the same power as the index. If you don't remember what the index is, right, if you had, let's say, the cube root of x, the index would be this 3 right here, right? So the index is just the number under your radical. If it's raised to a fractional exponent, you want to raise it to the reciprocal. I think I told you guys in class, instead of reciprocal, I would just say common denominator. And that's because sometimes you're not going to get the exact same fraction in your exponent, right? So just to clear that issue, just use the common denominator. It'll clear your fraction. All right, so let's do some examples. Now, number 9, we have cube roots here. Now, just like with the square roots, we want to get the radicals to one side. Now, we see 2 radicals here. All right, so let's get 1 on each side. All right, so let's first start by adding the cube root of x to both sides. All right, and it's going to cancel out over here. And so we're just left with the cube root of 4x squared minus 4x plus 1 equals the cube root of x. And now we have a cube root on either side, so we want to cube both sides. All right, and the cube root and the cube are going to cancel on both sides, so we're just left with 4x squared minus 4x plus 1 equals x. And now we're just left with the quadratic, so we want to get everything to one side, set it equal to 0. So let's subtract the x on both sides to get 4x squared minus 5x plus 1 equals 0. Right, and this is something that we can factor and solve. Right, now when there's something in front of the x, you want to multiply first times the last. Right, so what multiplies to 4 and adds to negative 5, the middle term? Right, is going to be negative 4 and negative 1. So we want to split up the middle term and say 4x squared minus 4x minus 1x plus 1 equals 0. And then group the first 2 and group the second 2. And then take a GCF from the first group, we get a 4x. And you're left with x minus 1. And in the second group, you can take out a negative 1. And you're left with x minus 1. All right, and so fully factoring this, we should get 4x minus 1 times x minus 1 equals 0. And then you want to set each factor equal to 0. So 4x minus 1 equals 0, x minus 1 equals 0, and you get x equals 1. And then here we can add 1 on both sides. We get 4x equals 1, and then divide by 4. We get x is positive 1/4. Now, because you have a cube root, right, so because this one is a cube root equation, you're allowed to have negatives under the radical with cube roots, right? So you don't need to check if these are solutions, right? You just get your 2 solutions, right? They're going to work, right? And that always works if you have a cube root or a fifth root or anything that you're allowed to have, negatives under the radical is fine, right? But all the square roots and the fourth roots we want to check, all right? So same thing over here. So these mean the same thing as the last problem, right? Just this time it's written in a different way. Hopefully we remember what a fractional exponent means. If I have something like x to the 1/3, right, the denominator becomes the index, right? So it becomes the third root of x, or cube root of x, right? So these mean the same thing. So we essentially did a problem like this just now. It's just written in a different way, and this is a perfectly normal way to write it, right? They're equivalent, right? So just like the last one, I'm going to get one of my expressions on one side, and I want the other one on the other side, right? We want the radicals or the fractional exponents now. We want it by itself. All right, so let's add one of them to both sides, then we get 3x plus 7 to the 1/3 equals 4x plus 2 to the 1/3. All right, and then we had said in the first slide, right, to get rid of that fractional exponent, you want to multiply by the reciprocal or the common denominator. These fractions are the same, so let's do times the reciprocal, which is just 3. Or not times, I'm sorry, raising to the power of 3. And then when you raise to the power of 3, you can do power to a power, which is multiplying. All right, and then you get 1/3 times 3 is going to go away, so we get 3x plus 7 equals, and then we get 1/3 to the 3rd power is going to go away as well, equals 4x plus 2. All right, it just becomes a linear equation. Right, so we can get x by itself, right? Let's subtract 3x and then subtract 2. All right, and then the 2 is going to cancel, and you're left with an x on this side, right? 4x minus 3x. And then over here, the 3x's are going to cancel, and then we get 7 minus 2 is 5. Again, you don't have to check this one because cube root or to the 1/3 power, you're allowed to have a negative under that, so it'll work. All right, now let's try some of these. Okay, looking at number 11. Now, our initial problem that we have, having the radical by itself, that's already taken care of here. We already have the radical by itself. We have the 4th root of x squared plus 6x equals 2, right? It's already by itself, so we can immediately raise both sides to the index, right? The index here, again, the index is the number under the radical. If there's a 4 under the radical, to cancel out that 4, let's raise both sides to the 4th power. And then the 4th root and the 4 are going to cancel. So you get x squared plus 6x equals 2 to the 4th power is going to get you 16. Right? You're multiplying 2 by itself 4 times. All right, and then this is just a quadratic that you guys are able to solve now. All right, so let's subtract 16 to both sides. And then we get x squared plus 6x minus 16 equals 0. And now let's see if we can factor it. That should always be the first thing you check, is if it can be factored, right? And this one can, right? You're looking for factors of negative 16 that add to positive 6. It's going to be a positive 8 and a negative 2, right? And then you want to set both of these equal to 0. So we should get x equals negative 8 and then x equals positive 2. All right, so fairly simple equation. This one's to the 4th root though. So this one, the negative under the radical is not allowed. Why don't we check it to see if our solutions are valid? All right, so let's first check x equals negative 8. All right, so checking x equals negative 8, we want the 4th root of negative 8 squared plus 6 times negative 8, all right, equals 2. Let's see if this is true. Negative 8 squared is going to be a positive 64, right? Negative times negative is positive. And 6 times negative 8 is going to get you a negative 48. All right, and it's that's under a 4th root, equals 2. And then 64 minus 48 is going to get you 16. So we get the 4th root of 16 is 2. Is this true? It is, right? 4th root of 16 is 2. We get 2 equals 2, x equals 8 is a solution. Let's do the same thing with x equals 2. All right, let's check x equals 2. And we should get 2 squared plus 6 times 2, all under a 4th root equals 2. Let's see if this is true. 2 squared is 4. 6 times 2 is 12. And this is under a 4th root. And then 4 plus 12 is 16. So we get the 4th root of 16 is 2. And the 4th root of 16 we just said was 2. All right, so this is true as well. All right, so both of our solutions work. All right, and now let's look at the next one. This one's a little bit of a tough one, and it's not tough just because of the concepts, right? The concept is exactly the same as the last few, right? The only reason why this one is a little bit more difficult is because you're going to end up with really big numbers, right? But I'll do this with you guys, right? So just like in the previous slide, we had a fractional exponent. The way that you want to get rid of that is by raising it to the power of the denominator or the reciprocal, right? So let's raise, we only have one fraction here, so let's raise it to the power of 4 to cancel out that 1/4, right? Power to a power, you can multiply the powers, and then 1/4 times 4 is going to cancel out. So we get 3x squared plus 52x equals 4 to the 4th power is going to get you 256, right? You can verify that on your own. You can multiply 4 by itself 4 times. It should get you 256. And now this is a quadratic equation that you want to set equal to 0 and see if you can factor it. So let's minus 256, or let's subtract 256 on both sides. So we get 3x squared plus 52x minus 256 equals 0. And the first thing you want to check is ask, is there a GCF, right? Here there is no GCF, right? So you have to find what multiplies to 3 times negative 256 and adds to 52, right? So 3 times negative 256, right? If you can't do that in your head, do it off to the side, right? 256 times 3 should get you, I think, 768, right? Something like that. All right, yeah, 768, right? So negative 768. What multiplies to this and adds to positive 52. Again, this is maybe the hardest problem in this section just because the numbers are so big. Now, upon thinking about this for a little bit, you should hopefully come to the conclusion that this can be factored into a positive 64 and a negative 12, right? They multiply to negative 768 and they add to positive 52. All right, so you want to now split up your middle term, all right, into a plus 64x minus a 12x, all right, and then subtract 256, and then bring down the 3x squared. All right, and now you want to group the first two and group the second two, and then pull out a GCF from each. It looks like in the first one we can pull out an x, and so we should be left with a 3x plus 64. All right, and in the second one, we can pull out a negative 4, and then we should be left with the same thing, right? We should be left with a 3x, right, plus 64 equals 0. All right, and since the insides match, we can bring the GCFs into one factor. So we get x minus 4 times 3x plus 64 equals 0. And then set each of these equal to 0. We should get x equals 4. All right, and then here we should get x equals negative 64 over 3. Now you really should check these. I checked them earlier. They both work. I can show you that here, right? So plugging in 4, right? I'll do that off to the side, right? It might take a little bit of work. All right, so we can check x equals 4. So we get 3 times 4 squared plus 52 times 4, right? And this is all to the 1/4 power. We want this to equal 4. Let's see if this is true. Now remember that 1/4 in the exponent is the same as the 4th root, right? So this is the same as if I were to write it as the 4th root of x. Of this expression, right? And the 4th root of what is going to get you 4, right? We kind of just did something like this. We just raised 4 to the 4th power and we got 256, right? So we're looking for if the underneath the radical is equal to 256, all right? And then 4 to the 2nd power is going to be 16, so we get 3 times 16 plus, and then 52 times 4 should get you 208. And then we want to see, does this get you 256? And then 3 times 16 is 48. 48 plus 208 is going to get you 256. So we get the 4th root of 256 is 4. That is true, right? So x equals 4 is a solution. And then we can check negative 64 over 3, right? So I'm going to check that one as well. All right, so we get 3 times negative 64 over 3 squared plus 52 times negative 64 over 3. And this is all under a fourth root, right? So again, we want under the radical to equal 256, right? So let's check. 64 times 64 is going to get you a big number. I believe it's about, what, 4,000? Yeah, I think it's 4,096. All right, so we get here that this is equal to 3 times 4,096 over 9, right? We're squaring the top and squaring the bottom. All right, and this is plus 52 times negative 64 should get you negative 3,328. Again, you can verify that off to the side. I had done this work before. Over 3. And here, underneath here, the 3 and the 9 can simplify. So we get 4096 over 3 plus negative 3,328 over 3. All right, and let's see what this gets us. So this is going to get us 4,096 minus 3,328 should get you it should just get us 768, right, over 3. Right, fourth root of this. All right, and then when you divide it by 3, you do indeed get 256 equals 4, right? So that it works. All right, both of our answers work here. All right, I know that was a tedious process, and I know I kind of skipped a lot of the work. On your own, you should be checking it each and every single time. But again, this was a little bit of a trickier one. All right, so let's just try 2 more. As always, you want to clear a fractional exponent by raising both sides to the reciprocal. But notice the exponents here are a little bit different, right? 2/5 is not the same as 1/5, right? So the easiest way to do this is first raising both sides to the power of the denominator, a common denominator. And they share a 5 in the denominator, so let's raise it to the power of 5. All right, and then on the right, 1/5 times 5 is going to get you 1, right? So it's going to cancel out completely. We get 4x. And on the other side, 2/5 times 5, right? The denominator is going to cancel with that 5. So we just get x minus 3 squared, right? And if you're not comfortable with that, you can write it out, right? 2/5 times 5 is the same as times 5 over 1. And then the 5 and the 5 cancel, and you're just left with 2, right? So we get x minus 3 squared equals 4x, right? Let's FOIL this out, right? Again, do not distribute the square, right? So we want to write it twice and FOIL it. So we should get x squared minus 6x plus 9 equals 4x. All right, and now let's subtract 4x on both sides. Let's set this entire thing equal to 0. So we should get x squared minus 10x plus 9 equals 0. And then you want to see if you can factor it. This one you can. There are numbers that multiply to positive 9 and add to negative 10. Should be negative 9 and negative 1. All right, and then so we should get x equals 9 and x equals 1. And then again, 5th roots, you're allowed to take the 5th root of a negative number, so there's no need to check here. It's going to work. All right, so these solutions are fine. All right, and then let's look at the last one. All right, so again, you want to raise both sides to a common denominator. Now in this case, 3/4 and 1/2. The least common denominator is going to be 4, right? Between 4 and 2 is going to be a 4. Let's raise both sides to the 4th power. All right, and then on this side, 1/2 times 4 is going to become x squared. And then on this side, right? Don't make a mistake here of just raising 3/4 to the fourth power, or x to the 3/4 to the fourth power. Since this 3 is being multiplied to this x to the 3/4, you have to bring both of these factors to the fourth power. So this is going to become 3 to the fourth power, x to the 3/4 to the fourth power. All right, and notice this is different from the last one, right? Notice that the last one we had parentheses over that 4x, so that when we raised to the fifth power, right, the 1/5 went away and we were just left with 4x. We don't have that here. The only thing that's being raised to the fourth power is the x, right? So that means when you raise both sides to the fourth power, right, the 3 also needs to be raised to that power as well, right? Not in a group like this, right? The parentheses make a difference. All right, so let's continue this one. 3 to the fourth power is going to get you 81, and then x, or 3/4 times 4, the 4 and the 4 are going to cancel. We get 81x to the third equals x squared. All right, and now we want to get the x squared to the other side. So let's subtract x squared. We should get 81x to the third power minus x squared equals 0. All right, factor the x squared, and we get 81x minus 1 equals 0. And we get x squared equals 0, 81x minus 1 equals 0. And then over here, when we take the square root of both sides, we should get x equals plus or minus 0, but there's no such thing as plus or minus 0, so we just get x equals 0 twice. Right, we get the same answer twice. You don't have to write the twice, I just need to see that you at least have x equals 0, right? But this is just for you to know that that's where 2 of our solutions went, to x equals 0. And then now let's add the 1 on both sides and solve for x over here. We get 81x equals 1. All right, divide both sides by 81. And we should get x equals 1 over 81. All right, and we get 2 solutions here. Now this is an even root. You see an even number in the denominator, so we can check it. Right, the easiest one to check is 0. Right, let's see if 3 times 0 to the 3/4 is the same as 0 to the 1/2. Right, and it is, right? Anything to the, or raising 0 to any power is going to become 0. Right, and then 0 to the 3/4, that's still 0, and we get 3 times 0 is 0, right? That is true, right? 0 equals 0. So this is fine. And then 1 over 81. All right, so let's check x equals 1 over 81. Right, so we should get 3, 1 over 81 to the 3/4 equals 1 over 81 to the 1/2. All right, and then the fractional exponents, these are the same thing as radicals. Right, so this becomes 3 times the 4th root of 1 over 81 to the third power equals the square root of 1 over 81. And then the square root of 1 over 81, you can just square root the top and square root the bottom. Right, if you're dividing under a radical, you're allowed to do this. This becomes 1 over 9. All right, and then the 4th root of 1 over 81. Same thing, you can 4th root the top and 4th root the bottom. We should get 3 times 1 over 3 to the third power. And then again, same thing with the radicals, you can raise the top and the bottom to the same exponent. So we get 3 times 1 over 27 equals 1 over 9. And then 3 over 27 is going to get you 1 over 9, right? So this one works. All right, so both of our answers work here. All right, and that's it for this section.